Hey everyone, today we're going to be building off of the lesson we had yesterday, which was factoring a polynomial that looked like x squared plus bx plus c. But you can see the biggest difference for today, and it does actually make a very big difference in terms of how we go about solving the problem or factoring it, is now there's going to be a number in front of the x squared value. Yesterday, every single example we did just started with a regular x squared. However, all of the examples that we're going to see today are going to have a number in front. So it might be 2x squared or 5x squared, something along those lines. And whenever we have that a value that's something other than 1, it's going to change the process that we use in order to help us factor the problem. Now, what you'll see is we actually end up doing the same thing that we did yesterday, but there's a step we have to take prior to that. Then we also incorporate some factoring by GCF as well. So this type of lesson actually encompasses most of, if not everything, that we've already done up until this point. So let's take a look here. How do we factor anything that's ax squared plus bx plus c? So now again, there's a number in front of the x squared. What we do is we call this the AC method, or I've also heard it referred to as borrow and return. And you'll see where that comes from in just a second. But all of these steps are given. We're going to multiply the a value and the c value together. And then we're going to replace that original c value with the new number we get. From there, we're going to treat it like a regular factoring problem that we did yesterday. Once we find out what our two factors are that we're going to work with, we rewrite the original problem, but what we're going to do is we're going to take this b value and we're going to split it into the two factors that we found, and then we're going to make two groups, the first two terms and the second two terms, and we're going to factor out the GCF and get our final answer. So let's just jump into a problem right away. Here you'll see a problem that's already worked out for you. What we do is we take the a times the c. So 3 times negative 6 is negative 18. So what you can see is what we did was we took that 3, we borrowed it to get the negative 18. And then you see the 3 that used to be here is gone. We borrowed it to get the negative 18 at the end, and the negative 7 stays untouched. Now, from there, we factor this just like we normally did. What two numbers are going to multiply to negative 18 and add to negative 7? That comes out to be these two terms right here, negative 9 and positive 2. So once we get those two terms, we return back to the original problem. So you see the 3 made its way back, 3x squared. But we're going to take that negative 7x and we're splitting it into the two terms we just found in the problem, or in the step above, negative 9x and 2x. And then this negative 6 that we started with goes back. So again, we only borrow that 3 temporarily to allow us to factor. Once we factor, we just go right back to the original problem. Then, as I mentioned before, we are going to group the first two terms together and the second two terms together. And when we look at this first term, I could take a 3 out of both the 3 and the 9, and I can take 1x out of both terms. So I take a 3x out, and I'm left with x minus 3 in the parentheses. Whereas over here, I could take a 2 out of both a 2 and a 6, but I can't take an x out because this negative 6 doesn't have an x, and when I take the 2 out, I'm left with x minus 3. And then what you'll notice is inside both sets of parentheses is the exact same thing. That's our check to make sure we did it right. So when we have our final answer, we could see x minus 3 is one of our factors. The other factor is whatever's on the outside of parentheses, 3x plus 2. Okay, and there's our final answer. So all those steps are written there for you, broken down so you have a nice visual. But let's go ahead and take a look at an example. So in this case, we have 2x squared plus 17x minus 9. We don't want that 2 out in front, so what we're going to do is we're going to borrow it over here to the negative 9. 2 times negative 9 is negative 18. So what I'm going to do underneath is I'm going to rewrite the same expression without the 2, okay, because it was borrowed, and instead of the negative 9 at the end, I'm going to replace it with the negative 18 that we found. From here, we ask ourselves, what two numbers are going to multiply to negative 18 and add to a positive 17? Now, you can make your factor list like we did yesterday, or if we're getting better with just kind of recognizing our number patterns, we may recognize right away that this is going to be a negative 1 and a positive 18. Negative 1 times 18 is negative 18. Negative 1 plus 7 or plus 18 is 17. Okay. So here are my two factors. So what we're going to do now is I'm going to go back to the original problem. The original 2x squared. But now I'm going to split that plus 17 up into the two factors we just had. Minus 1x plus 18x. Taking these two factors and splitting it. And then I go back to my original, which was minus 9. Once I get to this point, I'm going to group the first two parts together, and I'm going to group the second two parts together. And from there, I'm going to ask, what can I take out of each of these? So numerically, I can't really take anything out other than a 1, right? And then as far as the x's go, I could take 1x out of each. 2 divided by 1 is still 2. And if I take 1x out of x squared, I am left with x. Now I've got my minus sign. And if I take a 1 out of 1, I get 1. And if I take x out of x, I've got nothing left. So if I take 1x out, I'm left with 2x minus 1. Okay. Now when I look at my second term, I see a plus 18x, I see a minus 9. I could take a positive 9 out of each, so I'm going to write plus 9. And I can't take an x out of each, so when I do this, 18 divided by 9 is 2. The x comes down, and then negative 9 divided by 9 is negative 1. And as we mentioned in the example before, we can see that the two values inside the parentheses are the exact same. So that's going to be one of my answers, or one of my sets of parentheses, 2x minus 1. And then the other set of parentheses comes from what's on the outside. That's a bad color. 1x plus 9 and there's our final answer, 2x minus 1, x plus 9. Okay. So let's see a second one here. 6x squared minus 7x minus 5. I'm going to take that 6 and borrow it over. 6 times negative 5 is negative 30. So I rewrite x squared minus 7x minus 30. Again, I'm not including this 6 because it was borrowed to the end to get to negative 30. Now from here, I think what numbers are going to multiply to negative 30 and add to negative 7? And that's going to be a positive 3 and a negative 10. 3 times negative 10 is negative 30. 3 minus 10 is negative 7. So those are my terms. From here, we go back to our original problem. 6 x squared. But I'm going to split this negative 7x into these two, plus 3x minus 10x, and then back to the original again, minus 5. I group the first two together. I group the second two together. Looking at the first one, now it's GCF. I could take a 3 out of each, and I can take a single x out of each. 6 divided by 3 is 2. X squared divided by x is x. 3 divided by 3 is 1. X divided by x is 1 again. So I have a 3x on the outside, 2x plus 1 on the inside. Now when I come over here, I never want a negative in front of this x. So what I'm going to do is I'm going to end up factoring the negative out. Okay, I'm going to factor the negative out, and then when I think about what the GCF is between that 10 and that 5, it's going to be a 5. So I factor the 5 out, and it's actually a negative 5. So when I have negative 10 divided by negative 5, that's a positive 2. And then x, no x on the outside, so it just comes down. Negative 5 divided by negative 5 is positive 1. So we want to be very, very careful when we are dividing by a negative or when we factor the negative 5 out. But again, you can always do that final check. Is what's left over in the parentheses the same? And it is 2x plus 1. So 2x plus 1 is my first set. My second set is whatever's on the outside. 3x minus 5. Okay. And so if you feel like you're getting comfortable with this, you can try the last two on your own. We can watch another one together. Remember, if at any point you want to check afterwards, if you want to try a problem on your own and just check your answer, go ahead and pause the video, try the problem, and then start playing the video again to see. Okay. Otherwise, I'm going to continue on. Problem 4. I'm going to take that 4 and borrow it over. M squared plus 19m. 4 times 12 is 48. So I'm going to replace that 12 with a 48. And I'm going to ask myself, what two numbers multiply to 48 and add to 19? Okay. So again, I know I've been kind of jumping ahead and just picking the two numbers right away. If that's still a struggle for you, let's take a look and write out our factor list. So 1 and 48 multiply to 48, but that adds to 49. 2 and 24 multiply to 48, but that's going to end up being 26 when we add those together. 3 and 16 are going to multiply to 48, and there's our winner. 3 and 6 add to 19, which is what we had here. So remember, at this point, what we do is we rewrite the original problem. 4m squared, but then I'm going to split that 19m into a 3 and a 16, plus 3m plus 16m, and now I take care of the plus 12 from the original problem. Okay. At that point, I clump the first two together, clump the second two together. What can I take out of both a 4m squared and a 3m? Well, 4 and 3 don't have any common factors, but m squared and m, I could take a 1 out of, an m out of each, and I'd be left with 4m plus 3. When I look at the second set, I can take a 2 out of 16 and 12. I could take a 4 out of 16 and 12. And that's it as far as what I can take out of both. So I'm going to take out a 4, and it's a positive 4, so I'll bring the plus sign out. And then the 16 has an m, the 12 does not, so I can't take any m's out. So 16 divided by 4 is 4, and then the m comes down, plus 12 divided by 4 is 3. 4m plus 3 is inside both sets, so we know we did this correctly. 4m plus 3 is the first one, and then whatever's on the outside, m plus 4 is the second set. Okay, so if you haven't tried one of these on your own yet, go ahead and try it now. Example 5, pause the video, check your answer when you're done. Okay. So w squared minus 12w, 9 times 4, 36. So now what is going to multiply to 36 and add to negative 12? So 1 and 36 is 37. 2 and 18 is 20. 3 and 12, 15. 4 and 9, 13. 5 doesn't go into 36. 6 and 6, there's my 12. However, we see that this is a minus 12. So if you refer back to yesterday, negative 6 times negative 6 is still positive 36, but negative 6 plus negative 6 is negative 12. So we found our winners, negative 6 and negative 6. That's what we're going to split the negative 12 into. Okay, so at this point, I rewrite the problem. Originally, 9w squared, but I'm going to take this negative 12 and I'm going to split it. Negative 6w minus 6w, and then plus 4, the original. I'm going to group the first two, group the second two. What can I take out of both a 9 and a 6? That's a 3. W squared and w, I can take one w out of each. 9 divided by 3 is 3. W squared, take out a w, and I'm left with 1w. Minus 6 divided by 3 is 2. W, take out a w, there's nothing left. So there's my first set. Okay. And as we mentioned before, we don't want that negative out in front. So I'm going to take the negative out. And then what can I take out of both a 6 and a 4? I could take a 2 out of each. So negative 6 divided by negative 2 is positive 3. And then the w comes down. Positive 4 divided by negative 2 is negative 2. And just as we'd hoped, same thing inside the parentheses. 3w minus 2. And then, again, on the outside is another 3w minus 2. And that is our final answer. Okay? So hopefully by seeing these examples and practicing some on your own, you're feeling pretty good about this and have some confidence. But of course, if not, I understand that through a video, it may not be the easiest way to learn. So if you do have questions, always feel free to email me or send me a message through Schoology, and I will do everything I can to help you better understand. Thanks for watching, and we'll catch you next time.